In the previous video, I have shown you the overview of Maze Runner. So in this video, I'm going to break this down step by step, starting with how to install the Maze Runner CLI tool. Here in my IDE, I have opened the GitHub repository, the README file. And you can see the three usage modes. First is the manual development. We write everything. We write the manifest, the test, and the implementation. On the second usage mode, we are using AI tools to suggest code and create the manifest, etc. The third one is what I have shown you in the previous video, the fully automated mode. In this video, I'm going to use the AI assisted mode using Claude Code. If we scroll down a bit, we can see how to install Maze Runner. So I've already installed this in my project here. So if I install it using pip, it's already audited. So if I run made version, we can see the latest version is 0.5. I recommend using UV because it's easy to use. Now let's review the current project structure here. So this is a Maze Runner MCP server project. This is set up so that it will work well with Maze Runner. If I come here to the issues, I'm using the Maze Runner repository to track the issues even if it's going to be implemented on a separate project. So for today, we're going to implement the MCP server. So there's an epic for that, and particularly we're going to implement the MCP server foundation. Okay, so this is the issue details, but basically we just want to establish an MCP server that is working with all the tools available with the Maze Runner CLI. So to start with, what we need to do is to initialize Maze in this project. And to do that, we can run UV run Maze init. What it will do is it will create the manifest, the test directories. It will create docs directory. It will copy these to documentation. It will update the cloud.md file if it exists. It will show several options to append, overwrite, or skip. So generally, we want to append so that it won't overwrite our own cloud.md customizations already inside. Now, it's asking us to copy the Claude Code agent files. So yes, as well as the command files, the custom/commands. Once we do that, we can see the changes here, and the agents, I will explain this as we move along, will be used to work with this project via the Maze methodology. And also the corresponding custom/commands will be used to call the agents. And as I mentioned earlier, it also created this documentation directory where the Maze specification is placed, as well as some general unit testing rules to write an effective behavioral test, not implementation detailed testing, but a reliable unit test. And if we go to the cloud.md file, we can see the changes here. The init command inserted this Maze methodology section that introduces how to work with Maze. So that's how Maze init works. So let me just quickly commit all of this so that we have a clean slate. Alright, so the next one is I'm going to use the spike command. Spike means it's just an exploration of an idea. Here we are saying to explore this idea and then come up with a plan. Basically, that's how spike works. So let me clear this terminal up and then let me fire up Claude Code. I have set up CCD for Claude Code bypassing the permissions. I will use the spike custom command and then tell Claude Code to explore this issue number 89. It correctly found the GitHub issue, and along with the prompt that I have mentioned, Claude Code will explore in the current project to find out how to implement this issue. Alright, so we can see here that we have a plan. We can see the spike summary for issue number 89, and it correctly identified the correct Maze Runner commands. And here is the important part, the breakdown of the task, one manifest per file. So we will come back to this response by using Claude Code forking. I will show you how to do that later. We can see here that the first task is the blank server creating this file. So we can refer to the task by using the task number here. To start, we need to create the manifest. So to do that, we will use the generate manifest custom/command. Once we do that, Claude Code will call the sub-agent Maze manifest architect to create the manifest for task 001, which is the blank MCP server. So it has that context. Now it's running, it's creating the manifest. Let me switch to the version control so we can see which files are being created. Now it started to create the manifest. So the manifest validation passes schema only mode. We can see the typical made manifest here. The creatable files does not exist yet, and the expected artifacts, create server, the main function is also here, as well as the to be created behavioral test to validate these expected artifacts if it is working or not. So the sub agent has successfully created this manifest. Now the next step is to generate a test as suggested here. Made methodology is built on top of the TDD methodology, which is the test-driven development. I can simply say task 01 here, and Cloud Code will have that context already. And as we can see here, Cloud Code is going to use the made test designer agent to create the behavioral test. It reads the manifest, and now it's exploring the code, and it's looking for the implementation. Since this is TDD, it means we don't have the implementation yet. So if we run this test on its own, it's going to fail, which is normal. And we can see what will happen next here. And we can check the output of the behavioral test. So now made will validate this, but the intention is not to make this pass yet, because this will certainly fail. The intention is to make sure that the functions or the expected artifacts mentioned here are being tested here. And let's check. Yes, so the validation results, which is the behavioral mode, is passing, meaning the created unit test here are calling these functions. And we can see the red phase confirm the test will fail as expected. Okay, let's proceed. So the next step is to implement the actual code, phase 3. We can fire that up by using implement custom / command and just mention task 001 here. We can see the Cloud Code also suggested an option 2, manual implementation following TDD, but that's not what we are aiming for here. We're aiming for developing this via the made methodology. So now the made developer agent or sub agent is implementing the code itself. It's creating the server.py, which is mentioned here. And the goal is to implement this in such a way that the expected artifacts exist in the created server.py. So if we open the file, we can see that there's a create server and there's also the main function here. So this is the power of made methodology. We are controlling which functions, which classes should be implemented. But the AI is free to implement the internal private implementations. So we have that breathing room for the AI. So the validation here is the complete TDD validation, meaning this test should pass, and the made developer sub-agent will make sure that this file will pass this test. It looks like it's done. Says the blank MCP server task has been completed. 100% validation success. But let us check ourselves. Let me open a terminal here, and then let me show you how to do this validation manually. You can do that by running made validate without any arguments, and we can see the validation here is passing 100%. We have one manifest only for now, and we are shown with the file tracking analysis, which shows us which files are registered, which files are not tracked, and this is the most important line. Everything passes, but that doesn't mean that this code works already. To verify that, we need to run this made test. So let me run uv run made test. Alright, so this is passing test. We can even use PyTest here. I have implemented the make commands to show this working, and we can see that more information here. All 12 tests has passed. So now we have a running blank server. And now I'm going to show the Cloud Code forking to implement the next task. So if we take a look at the conversation so far, we started with Spike, generate manifest for task 1, generate test for task 1, as well as the implementation. So what I will do is I will time travel, so to speak. I will go to the generate manifest from here, restore the conversation, and this time I'm going to say generate task 2. So this is a technique to preserve the Cloud Code context. But since Cloud Code at this point doesn't know that we already implemented task 1, we have to mention it here. Let's proceed. So now it will do the same thing. It will call the made manifest architect sub-agent to create the next manifest. We just added the task 01 is already implemented just to have some kind of hint and direct it a bit to avoid any confusion. And it says it created a file. Let's see what it looks like. It will now create the init file for the tools. And if we take a look at the plan here, the first tool to be created is at task 003, the made validate tool. Alright, so let me proceed with the next step, generate test. Okay, so it created the validation test or the behavioral test. Now let's proceed with the phase 3, the implementation. I made the typo, task 003. We need to implement task 02 first. Okay, so it looks like it created the file. Let's see. Let's open it, put it here. It's just a simple file. Okay, it's done. Now it says it's ready for task 3. As we had done earlier, we need to make sure. So let me clear this up. UB run made validate. Okay, so to manifest passing. We can also use make test. Everything is passing, so let me just ask Cursor's help, commit the changes and fix any issues you can find. It's also been instructed to use the made validation, so that's why it's running the make validate as well as the git commit hooks. Again, we're going to fork from the current conversation so that we have the new file here. So this is the most important file to be created, the first MCP server tool. So let's proceed with that. Okay, let's revisit what's happening right now. So we can see that we have several manifests now. We have two tests. And if we go to the source folder, we have the tools created here. We also have the server created here. So everything is progressing. All with 100% passing tests and all with made validation coverage. Meaning if we change or rename any functions here, the made validation will fail. So that's the beauty of the made runner validation. Let me proceed with the next phase, the generate test. Task 003. It should generate this file, test task 003 made validate tool, which will validate all the expected artifacts here. So this is not just creating blindly the unit test for this file, but made validation will make sure that all of these expected artifacts are actually being used or called in this behavioral test or the validation command. Cloud Code fired up the made test designer sub-agent to create the behavioral test for task 003. And we can see here, if we scroll up, the status of the validation. Cloud Code intelligently executed the schema validation, meaning if this manifest file complies with the schema. So we have the made manifest schema. We can see it by running uv run made schema. And this is the JSON schema for the made manifest file. So that's why it was able to create or validate the schema of this manifest. Okay, looks like the test is done. So let us proceed with the next phase. Implement task 003. So now it will create this file with all of these functions. All right, it's done. What I'll be showing you now is how to implement each task in one go. We can use the made run custom command. Okay, so let's try that. Task 004. So we can say, okay, so this will do all the steps. Creation of the manifest, generation of the validation command or the behavioral test, as well as the implementation. Made validate passes, made test also passes. By the way, in my git pre-commit hook, I'm also integrating the made validation as well as some linting. This is additional safeguard to make sure that we have good and high quality code before committing. Okay, let me fork, restore conversation. Okay, now I'm going to attempt to implement the remaining tasks 5 to 8 using parallel sub-agent. Okay, so it uses 4 task agents. Nice. Task 08 is done. We can actually run made validation here. For all of them are passing. That's great. How about the test? All of them are passing. Fantastic. How about all the tests? Nice. We do have 125 tests now. Looks like Cloud Code successfully did a good job here. So now maybe you're thinking, we have the TDD, we have the linters. Now we have made validation. Is it too much? I guess, in my opinion, I would say there's no such thing as too much with software development. Especially now that we're using AI. We have to drive or to control AI more and more rather than the AI controlling us. And made validation and made methodology, in my opinion, is the best way to do that right now. All right, let me fork. The next task is to implement the integration. So I will use made run here for the final task in this video, task number 9. So we can see here the phases of the made methodology very clearly. Phase 1 is the creation of manifest, this manifest, and now we can see the task type is edit. meaning it will edit an existing file, which is the server file, and then it will refer to the created MCP server tools, and we have this new test to be used as a validator, or the behavioral test validation command. This will ensure that all of the created MCP tools will be integrated to the server. And if we take a look at the original issue that we're working on, this is the foundation. So we are only going to implement the core tools. We do have other MCP server tasks here or issues here, like the resource and the prompts, but that's beyond this particular video. I think we're getting there now. So this is just the final validation, and now it's done. And we can also commit the changes and fix any issues. Now we can go to Cursor to test this. Let me do that now. Let's try this. You should be able to see 6 tools here. Oh, there you go. We have 6 tools now. Now let me rerun this. All right. Yes, can you try the Maze Runner MCP server? All right, looks like it's working. To recap, we have used the MADE methodology to implement the Maze Runner MCP server. And we have created several manifests here for each task, as well as the behavioral unit tests for each of the tasks, making sure that the implementation, as we can see here, are properly implemented. So this has been possible due to the MADE specifications, as well as the Cloud Code custom sub-agent and Cloud Code custom / commands, as we saw in the demonstration. So this shows us that using MADE methodology helps us to implement software more effectively. That's it for this video. I hope this helps. If you have any questions, please let me know in the comment section. As always, thanks for watching. Happy coding.